Hello everyone, today we start with this question. In this question, the question asks about an organic compound P produce a meso compound upon oxidation with osmium tetroxide. The compound P is. They give four options. First, this question we knows these terms they are giving in option. Like here they give EZ, EZ. So first we know about EZ isomers or EZ phenomena. What is the E and Z represent here? If we take one double bond or we take one alkene group, if one double bond have four different substituents, so here we assume high priority group is in this molecule. High priority groups are A and B, and low priority groups are C and D according to this compound. So if we saw here A and B, in this compound A and B they both are same side and they both are high priority groups. A and B they both are high priority groups and they both are at same side. So we called Z isomer. If these A and B high priority groups are opposite sides, so we call this phenomena E isomer. And how we remember this thing E and Z? So it is a very short trick. You always apply E, always remember with enemies. And you all know enemies are never be one side, they both always be a opposite direction or opposite side or different sides. So you remember this thing, E isomer connect with this E to enemies and they both are opposite planes or opposite sides, so it is a E isomer. So you saw in these option they give two E isomers and two Z isomers. So now you know about E and Z phenomena. Here they give 4 octane, here they give 3 octane, here 4 octane, here also they give 3 octane. And they are giving in this question our reactant P react with osmium tetroxide and give one meso compound. So first we know about what is the meso compound. If we know in these kind of terms, we can solve question very easily in examination. So in meso compound, you always remember one thing. In meso compound, two chiral carbons are present. Two chiral carbons are present. It is a must condition. And second thing is, it is in meso compound, plane of symmetry also present. Plane of symmetry. So compounds, you always remember one in meso compound. You always remember one thing. Meso compound always have plane of symmetry, and it always contain two chiral carbons. It is must. So what is the meaning of plane of symmetry? When you saw the compound, it will appear at symmetrical. So if you apply one mirror plane, it is super impossible to each other. So it means compound is our symmetrical and plane of symmetry present. So now you know about E and Z phenomena, and you know about meso isomer also. So now you can solve this question. Ask about organic compound P. If you saw in these four options, they give octane. It means our reactant is a one alkene compound. So here they give four alkene group, and we know that osmium tetroxide always give two diols. So here we check. So according to question, at the end we get meso compound. So in meso compound we learn about they give two chiral carbons are present and plane of symmetry present. If we saw in these four options, option A and option B only appear symmetrical, like uh, 3 carbons here and 3 carbons here attached to double bond, and here double bond attached 3 carbons here and 3 carbons here. It means they both are looking symmetrical. And here we saw option C and option D, attached to double bond, here two carbons are present and here four carbons are present. In option D also, here two carbons are present and here four carbons are present. They both are not looking symmetrical, they both are looking unsymmetrical, so we eliminate option C and D. Now we work with option number A and option number B. So first we react our option A react with osmium tetroxide. So here we know osmium tetroxide give 2 diol addition at syn. For our understanding, we draw hydrogen atoms like this, like one is on dash position and one is on wedge position. This is a wedge position hydrogen and this is dash position hydrogen. We draw like this only for to understand stereochemistry of this product. So here we mention like this. Osmium tetroxide, we all know osmium tetroxide add 2 diol at syn side or syn position. It means two hydroxyl group attached at same plane or sit same side. So here we saw it is our final product look like this. Here OH OH. If we convert in Fisher, CS3 H. Here first we number these carbon atoms so we can understand easily stoichiochemistry. 1 2 3 4 5 6 7 and 8, and 1 2 3 4 5 6 7 and 8 carbon. In our product, carbon number 4 and carbon number 5, two diol attached, but at different plane. Means one OH attached with dash and second OH attached with wedge position. So here we mention OH, they both are opposite sides. So here we apply plane of symmetry. Here we apply mirror plane here. So these two portions are not superimposable to each other, so it is not our meso compound. Here we saw we apply mirror plane, but these four carbons not superimposable to down four carbons, so it is not a meso compound. So now we check option number B. In B, option number B, we react osmium tetroxide with this reactant, so we get this compound. If we convert this to Fisher, we label carbons 1 2 3 4 5 6 7 and 8. Here we saw carbon number 4 and 8, like 1 2 3 4 5 6 7 and 8. Here we saw on carbon number 4 and carbon number 5 two diols attached, and they both are at a dash position. So we mention in Fisher projection like this. If we apply mirror plane, these part superimposable to this part, so this is a meso compound. This is a meso compound because this part superimposable to this down part, so it is a meso compound here. And here we saw plane of symmetry also present, so our option number B is correct. Thank you.